Hi guys, how's it going? We're going to do a little lesson today on the notes that we need on the unit circle. So we started learning about the unit circle, and if you have any questions, I'm going to have office hours on Tuesday, so stop in then. But the Delta Math is really like it guides you through things and it tries to like help you really understand how to rotate and everything. So I'm just going to go over the vocab. Take lots of notes. Okay. So I'm going to make this a little bit smaller and move it down here. So the first thing is the unit circle. So what that is, it's what we created the other day, and it is a circle with a radius of 1. So that is this right here, radius of 1. That's like each triangle we had where the hypotenuse was 1, and the center is at the origin. Okay, so you could write down that definition. The equation of the unit circle is x squared plus y squared equals 1 squared. So we're going to understand what that means right now. And the way that we're going to do that is there should be, oh, it didn't show up. I don't know where it went. Okay, so I'm going to do it on here then. So I'll make this a little bit bigger and put it in the middle so you can see me. Okay, there we go. So on here, okay, if we make one of our lovely triangles that we made the other day, the right angle right there, and, oh, you can't really see that, can you? There we go. There we go. Okay. And theta right here. Remember that this side right here from the angle was the adjacent side, and this side right here is the opposite side. Okay? So this is the x. So the x is the adjacent. Now, if you remember, the adjacent side was cosine. So this is the same as cosine. And this right here going up and down, that's the y value. Okay? And that was like the sine value, if you remember that from the other day, because sine is the opposite. Remember, opposite over hypotenuse. Now, if you think about a right triangle, Pythagorean theorem, a squared plus b squared equals c squared. Well, the c here is 1. So that's what this is saying. It's x squared, which is this side right here, plus b squared, which is this side right here, equals c squared, which is the hypotenuse of 1. And that's the equation of a circle. So that's where it comes from. Okay. I'll move this over. Alrighty. This is what this circle looks like. Notice where the coordinates are at 1, 0, negative 1, 0, 0, 1, and 0, negative 1. Okay. Now some important things. So the first thing is standard position of an angle on the unit circle. The initial side is on the x-axis and the vertex is at the origin. So you can pause this and take pictures of that. The terminal side, which is this right here, okay, is the side to which the angle is measured. I'm going to show you what this all looks like. Okay. So here we've got our unit circle. Okay. The terminal side always starts right here. Okay, so that's right here. Notice that the origin is right here at the origin of the center. Okay, 0, 0. And when we rotate, we're going to rotate like this. Okay, so we're rotating around the circle. So right inside here is the angle measurement. So far I've gone probably about maybe 50 degrees because it's a little bit more than halfway, right? Halfway would be right about there, and that would be 45 degrees. Now, if I keep going up this far, how far have I gone? 90 degrees. We all know what a 90 degree looks like. So if I keep going now, I'm going more than 90, right? So if I go like this, I've probably gone, let's see, it's 90 and then another 45. So that's about 135 degrees. And if I go in a straight line, if you remember from last year, that's 180 degrees. If I keep going, I'm now more than 180. So maybe if I go a little bit, I'm like 190. Now maybe it's about 200, right? Each time it goes a little bit more, okay? And if I'm down here, that's at 270, okay? Because you did 180 plus 90 more, that's 270. And now I'm going to just keep going. And if I go all the way around, I've created one full circle, that's 360. I could keep going and go more than 360. Like right now, I'm at about 380 or 390 because I went about 20 or 30 degrees more, like that, okay? So when we go in this direction, we always start at the initial side. Initials, that one right here. It's always on the x-axis and the positive side. Okay, so when we start, we always start at the initial side right here. And we start with the side and we're going to move up. So when we go in this direction, it's a positive angle. Doesn't matter how far you go. Again, we start here, but if I go the opposite way, if I go clockwise, now it's going to be a negative angle. So for example, if I start here and I move about that far, that would be like negative 30. If I move all the way down to here, that would be negative 90, maybe negative 100. So that direction is negative, that direction is positive. Hi again, sorry. So to continue, I'll leave this here for 1 second so that you can all take notes, okay? You can pause it and get notes on that. Quadrants of the coordinate plane. So you guys should know this. This right here is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we know which direction is positive. I would definitely take notes on that. Okay, so here are just some things that you're going to need to know, some vocab. So the first is what we talked about a second ago, a positive angle. Every angle starts here on the initial side, moves this direction positive. So positive goes counterclockwise. A negative starts in the same place, but moves this direction, goes negative, okay? Quadrant angles. So if an angle ends in the first quadrant, like this example right here, so you open up and then you stop right there, that's a quadrant 1 angle. For example, okay, if I start right here and I end somewhere here, I'm still in quadrant 1, so that's a quadrant 1 angle. Those are all between 0 and 90 degrees. If I keep going up and then I go past the 90 degrees, I'm now in quadrant 2, that's called a quadrant 3 angle. If I keep going and I go past 180, I'm in quadrant 3 angle. If an angle ends up on the axis, so like this, that's called a quadrantal angle, okay? I'm gonna move my picture so you can, okay, see that? And feel free to pause it at any point to take some good notes. Okay. Reference angle. So this is really important, and there's really good delta math on this. The acute angle formed by the terminal side of the given angle and the x-axis. I'm going to demonstrate what this looks like. So I'm going to make this bigger again. As big as I can. Move it right here. Okay. You were probably wondering, why is there this weird dangly thing? Let me show you. Okay. If I start here, oh, by the way, you may be asking why I'm in a onesie. I'm in a onesie because it was my friend's birthday party today, and so we did a virtual onesie birthday party because we can't see each other. Sad. Okay, so if you start here and you rotate and you go past 90 degrees, right? I can't make a right triangle if I'm past 90 degrees. So what we do is we drop this right here, so it goes straight down. Everything is opposite. Do you see the right triangle that just got created? Okay, can you guys all see that? I move it right here so I can demonstrate it. So there's a right triangle right here that just got created. Okay, that right triangle right there. Oh, forgot. That's why I brought these home. Okay. See that right triangle right there? Okay. So that's the right angle right there. This angle right here is called the reference angle. So this right here is the reference angle. And the reference angle is always between 0 and 90 degrees. It's going to help us make the right triangle so that we can do the sine and cosine because we need a right triangle for that. So the way you find it is think. If let's say this is at 105, you would say, well, if I went all the way here, I'd go to 180. So you do 180 minus 105, and that tells you what angle's right in here. Okay, so always think, where am I going to the x-axis? Let's say that now I went down, clean that up better later. I went all the way down here, okay? So now I would sketch out my right triangle. This would go straight up. So it goes straight up like that. Can't really see that well. Okay, and that would be the right angle right there. So this right here is the reference angle. Okay, you guys see that? So let's say that I had gone 200 degrees. Well, if this was 180, how much more did I go to 200? You do 200 minus 180, and that would mean that this angle right in here is 20-degree angle. That's your reference angle, okay? So that's what a reference angle is. Coterminal angles. So coterminal angles are two angles that end up in the same place. Okay, so you can pause it, get your reference angle definition. Okay, coterminal angles are two angles that end in the same position. So let's see here. Let's say I started on the initial, and I went up here 45 degrees. So I ended right here. That's my terminal side. Let's also pretend that I did the red one where I went negative 375. So this would have been negative 90, negative 180, negative 270, negative 370. That's not 375. That would be negative like 315. That means that it ends in the same place. Let's say I go 405 degrees. I went all around 360 and then, hey guys, I'm back. So we're going to finish up a couple last things on this lesson. Right here, you'll see, I'll get to that in a second, on the unit circle, if we have the adjacent side like we talked about, adjacent is cosine because that's adjacent over hypotenuse. Remember, sine is y. And since this is the x in a coordinate, the cosine is always going to go first, and the sine value is always going to go second. So that's just like the coordinates that you guys wrote on your unit circle. One thing to note is if you go this direction, the x is positive, right? So if you think about it, if the x is positive, that means the cosine is positive. And if you're up here, the y would also be positive. So the sine is positive too. So let's take this. One more thing. Pause this, write down these in your notes so that you have them. It's the same thing we just talked about. Okay, so if you look here, in the first quadrant, since x and y are both positive, sine and cosine are positive. And since tangent equals sine over cosine, it's also positive, because positive divided by positive. If we go into quadrant 2, here the x becomes negative, so that means cosine is negative. Sine is still positive because the y is positive up here. If you divide positive by negative, you're going to get a negative, and that's why the tangent is negative. In quadrant 3, coming down here, we have this x value is negative, the y is negative, so both sine and cosine are negative. When you divide sine by cosine, negative by negative, it equals a positive. Let me move myself out of the way. Okay. If you go into quadrant 4 over here, x is positive, but y is negative. So x again is cosine, positive, sine, negative. Let me scroll this so you can see it right there. And negative divided by positive is negative. So the way that we remember this, and this is how I was taught it back when I was in high school, is all students take calculus. So if you go quadrant by quadrant, A is for all, so they're all positive here. S is for sine, so only sine is positive in this quadrant. T is for tangent, only tangent is positive in this quadrant. And then C is for cosine, and only cosine is positive in this quadrant. But you can also just think it through and think about like, oh, is the x or y positive or negative in that quadrant? Okay. Pause this, write these down, and give me 1 second. Okay. And last thing. So if you remember, just a quick review of converting radians to degrees. Okay. I'm going to just go through one with you, and then you're going to do a bunch on your own. So remember on your unit circle paper that you have, hopefully you have it at home, you have the 30-degree angle right there. If you don't have it at home, just have someone else take a picture of theirs and send it to you, and you can just like sketch it onto a picture, onto a piece of paper or something. So we're going to put 30 degrees on the degree side over 360 because that's a whole circle. Remember that 2 pi was a whole circle in radians. We don't know the radians, so we put x up there. So now we're going to cross multiply. And this is exactly the same thing we did the other day. Okay, so we have 360 times x, 30 times 2 pi. Okay, so you get 360x equals 60 pi. Then we're going to isolate x. And we're going to simplify this. So we can divide 60 into both, and we end up with pi over 6. Okay? You're going to go ahead and do that with every angle. So with 45 degrees, with 60 degrees. And then we're going to think about this angle right here. So remember, this would be the one that was 60 right over here. Okay? What would this angle be? Because remember, we always start our angles there. So we went 90 degrees so far. We would go 180. If we went the whole way, it would go to 180 here. But we're not including this 60. See me erase that part? We're ending right here. So you're just going to take 180 minus 60. And that means that this angle is going to be 120 degrees. So on your unit circle, you're going to write all of the angles in degrees and then convert them to radians. You're going to take a picture of that and post it to the Google assignment. That's one of your assignments this week. Bye.